test I take, I get an A. Yeah, screaming that's none. When I pulled out the lock, that's done. Doing my thing, homework all day, every day. Triggers is it, triggers is it, triggers is it, triggers is it. Seeing Mr. Ng's face during period 3. Triggers is it, triggers is it.
Hey guys, let's go over 1.72 graphing a quadratic inequality. And let's just quickly review what we did in the last video. You have standard form and you can get a bunch of characteristics like the A value if it opens up or down, C value is your y-intercept. Steps to graphing, the end product when you graph it, less than or greater than will be dashed, and if it has an equal sign below, it will be solid. We're always trying to test a point, and we're trying to use the origin because it's the easiest, basically as long as it's not on the parabola. And then we shade accordingly. If it's true, then we shade that region. But if it's just false, we don't shade that point, and we shade the other region in the parabola or outside the parabola. Okay, your directions here, questions 7 to 12, go ahead and complete 3 and then skip 3. And then I realized that they kind of mixed up all these questions in here that are greater than, less than. So let's do number 7. All right, I notice I have my A, B's, and C's. So here's my y-intercept, positive 7, 2, 4, 6, 7. I know my A value is positive, so it's going to open up. Can we think of two numbers that multiply to be 7, but then add to be 6? I can't think of any, so let's go ahead and just put that into our graphing calculator. You can solve it by quadratic formula if you had a test that said no calculators do it by hand. X squared plus 6x plus 7. And negative 1.585, so that looks like it's going to be an irrational real 0. It's irrational because the number keeps repeating. And negative 441. Negative 441. And the other one, negative 159. Negative 159. Okay, these are my, wonderful, didn't save it. So these are my x-intercepts. I think previously we said this was our y-intercept. This was a 1, so it's going to open up. It's positive. And let's go ahead and put those numbers down. Negative 441, so between negative 4 and 5. Negative 1.59, it's a little bit past negative 1.5. And I should get my vertex. Negative 3, negative 2. Here's my minimum. Okay, let's go ahead and test this down. We're going to test this with 0, 0. And is 0 greater than 7? The answer is false. Don't shade. So we just tested 0, 0. And this area, all that area is false. So you're going to shade everything on the other side. And I also want to point out that you're only shading those that are above, no wait, number 7, yeah, that's right. Okay, number 8, same thing. I got a y-intercept of 17, so something way up there. This is a positive, so it's going to be going up. Let's put that into our graphing calculator. Switched it around. Okay, so you can see that this one has complex solutions, going to the x-axis. We can get a minimum for 1. Let's write that down. For 1. Hello, Miss Rain. Ta-da! Okay, let's test this. We're going to test the order pair 0, 0. Zero greater than 0 minus 0 plus 17. 0 is greater than 17. This is false. Don't shade. So this order pair right there we just tested, that all that region, don't shade it. Shade everything in the inside. So it's either inside the parabola or outside the parabola. Okay, number 9 doesn't look like it's factorable. You can use a quadratic formula if you wanted to. Let's get some characteristics here. Y-intercept is positive, so it opens up. You could just use a table of values, but this might be a little faster because we're trying to just focus on what the graph looks like, and then shading quadratic inequalities. Graph. Okay, we have a complex solution. So it doesn't cross the x-axis. There's my minimum, negative 1, 1. Let's test it now. Just putting 0, 0 back into the original equation and then comparing my results. Is 0 bigger than or equal to 2? That would be false, so don't shade 0, 0. So here's 0, 0. Okay. That means I'm going to shade everything on the inside. And my graph looks like it's actually going through 0, 0, but you can verify that by just looking at your graph. And remember, that was not the case. It's not going through 0, 0 there. Okay, number 10. So you can factor it out. I'm trying to get characteristics without, because you can factor out 2x. Okay, this is good, because then if you set each of those equal to 0, I basically solved where our 2 x-intercepts are. And that only works if you can factor or do the quadratic formula fairly quickly. I want to point out that C value in this case is 0. So that means it's going to go through here. A value is positive, so it's going to open up. Okay, so if those are your two x-intercepts, that means my axis of symmetry is going to go right down there. So x equals -1 is my axis of symmetry. So if you put in -1, you'll get 2 minus 4 is -2. So -1 comma -2 is going to be my minimum. Why is that a minimum? Well, because we know that it's graphing up. Does that make sense? Oh, please save. Thank you. Just not that last part. Whoa, whoa, whoa. And let's just go ahead and test this now. Is 0 bigger than or equal to 0? That is true. Now, okay, now I just realized this, of course. It's because it's on there. So I need to test another point. Let's test something like 1, 6. Or 6, 1, right? 6, 1. Can I count? Come on. 6, 1. This is what I'm going to test. X is 6, Y is 1. 36, 72, 24, 96. Is 1 bigger than that? That is false. Okay, that means don't shade the test point. Don't shade that. That means shade everything that's going to be inside that quadratic. Okay? And I have not been doing a great job. Okay, greater than or equal to, so number 10 is solid. Number 9 is solid. Number 8 should be dashed. Why is it dashed? Because you have just greater than. And same thing with number 7, should be dashed. Okay, number 11, let's get some stuff out of here. So A is -2, so this is negative, so it's going to open down. I got a y-intercept of my C value, +2. Let's see if we can factor out that negative. Nope, can't factor that. Okay, let's put that one into our graphing calculator, number 11. -2x squared minus 4x plus 2. Okay, -2.41 and 0.41. Double check that I have this right. Is it 0.41? It did. Okay, so these are our x-intercepts. Remember, x-intercepts have a number, then comma 0. So 0.41 is a little bit past, and -2 is between -2 and 3. And let's get the origin. -1, 4. -1, 4. -1, 4. Let's test. Okay, it doesn't look like it's going through 0, 0. And let's just see what happens here. 0 squared is 0. 0 times -2 is 0. -4 times 0 is 0. Plus 2, so I have 0 is bigger than 2. This is false. Don't shade the test point. What was the test point? 0, 0, which is on inside. So I can go ahead and shade everything on the outside. Everything in green is solution to the quadratic inequality. Everything that is not shaded, which is in the inside, for number 11 would be not a solution. And number 12, oh, I gotta make sure. That one is dashed. That means any point on the graph, the orange line, would not be a solution. And number 12. Looks like we could factor this. So I got a y-intercept. I know my a value here is positive 1, so it's going to open up. So if we can go for the home run, x minus 2 works. If you factored it, then you get x equals 2. And it's a double. So x equals 2. And then the graph's going to look like this. Now this is the axis of symmetry. How does that points work? Well, they're reflective. 2, 2. So I can do something like this. And if you graph that, x squared minus 4x plus 4. See? Two, 0, and y-intercept. So this is both a minimum and my x-intercepts. That ordered pair is actually both. Okay, let's just go ahead and test it, and then we're done. Of course it didn't save it. Well, here's a good thing. You can kind of rewind. Here's my hint if you don't go through your points. Alright, let's test this. Let's test 0, 0. Let me show you guys how to use the calculator. So I would just go to, you can go to table or table set. I have mine on ask. Now if you don't have that, you can just press second table. You can either do auto or ask. Where you want the table to start does not matter. I would start close to 0, and you want it to go by whole numbers. Whole numbers are integers. You see, this is why. So if I put in 0, I get a positive 4. What does that mean? You just don't like so that became, when you put in 0, you got 4. And that's false. Don't shade. So they're saying this point right here, that red point, everything outside the parabola don't shade. So we should shade everything else inside. Okay? Sorry that one didn't save the graph, but that's your answers for 1.72. We'll see you guys later. Bye.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.